Alright guys, in the last video we have studied how does the ADS-B protocol works and how does the PPM modulation work. And this time let's do the more interesting. Now let's track the aircraft in the real time using a MATLAB and a Pluto SDR device. Let's do this. Alright guys, so here we have a Pluto SDR device that the antenna is only connected to the RX side. Since we're going to receive the signal from the aircraft directly, we don't need any antenna from the TX side in the Pluto SDR device. Now let's receive the data from the aircraft using the MATLAB code. Alright, let's run the code so that if our Pluto SDR device can correctly receive the data from the aircraft and then decode their current position information so that we can do the real-time tracking. I'm going to run the program and specify runtime in seconds. I'll say 10. And then the signal source should be 3, the ADA-LM Pluto device. And launch the map, yes. Decode information, yes. Let's see. Alright guys, here we have some information coming from the aircraft. We have since I'm living in the Champagne, there is one flight that is going to the south of the Champagne, and we have a lot of information including the position of the aircraft, the name of the aircraft. So let's actually see if there is a real flight here. So I'm gonna type the flight ID here, EJA656. And then, yes, it starts from the Chicago and going to the, I don't know which city it is, but yeah, it's going south. And when I look at the map here, yes, here is a Champagne and it's going south. And as you can see here, my visualization is correct that it is going to the south. So I was able to successfully track the aircraft that is going around my home place. Alright guys, I have captured another flight that is going to the east, to the Indianapolis. So the flight ID is FTX3608, probably from the FedEx. And yeah, it starts from the Denver to the Indianapolis. And I was able to capture the signal when it passing through the south of the Champagne here and heading to the Indianapolis, while the actual signal says it's bit right. It's already past the Champagne. Well, there could be a delay since I'm using a weaker antenna or the Pluto SDR device compared to the real-time tracker. And this time, let's see how does the decoded information looking like. So here is my decoded information. These logs are containing every information that were sent from the aircraft and received by my Pluto SDR device, which containing the messages which can be converted into the binary bits. And then this data here on the left side, they are containing all the information required for the aircraft, which are the flight ID, status, and altitude, and etc. So let's see how it actually looks like. So at the beginning of the program, it has a bunch of no data. So it's not that weird because we need some time to receive the data from the aircraft. And then as you scroll down here, let's see when we capture the first signal. So we start from the 18 second, and then let's see when we first capture the signal and correctly decode it. Scroll down. It takes quite much time considering the distance between the aircraft and the my Pluto SDR device. And yes, here we received the first first aircraft information, which takes, how long did it take? Yeah, it takes about to be 30 to the 40 seconds. Let me scroll down this one again. Yes, we have another information here that contains the aircraft ID, and let's compare this one with our receipt data. Yeah, here we have aircraft ID correctly decoded. And then let me scroll down further. So at this point, we don't need any other information other than the aircraft ID. But as I scroll down more and more, yes, we have a Cartesian coordinate here that contains the information of the aircraft position. And yeah, we have this one. So we have a very heavy information coming from the aircraft, and we were able to successfully decode the aircraft flight ID. So it takes about to be 1 minute to correctly decode the information. So basically all the information here, it has some time delays and it has a lot of wireless channel effects, but we were successfully able to decode this information. So far, we have understood how does the PPM work and how does the ADS-B protocol work, and we also visualized by actually implementing this kind of modulation in our Pluto SDR device, and then we could successfully track the aircraft. I was really thinking this project was really cool because if you're interested in the flight that is flying all over your head, then trying by yourself, it's pretty much fun. But if you live in the suburban city where not much flights are flying, you may have hard time to find a flight, as my case. I have only like 1 or 2 flights that I can consistently capture. So if you live in the big city like Chicago or LA, then you will see much more flight than I do. And thank you for watching my video, and I hope you enjoy it. And I hope you try this by yourself. Bye bye.